Hello everybody, welcome to your first lesson in topic 8 on quadratic functions. We are going to talk about key features of quadratic functions today. So our learning target, we're going to be able to identify key features of the graph of the quadratic parent function. We will identify key features of the graph of a quadratic function using graphs, tables, and equations, and we're going to be able to explain the effect of the values of a on a quadratic parent function. All right, so you can see we have some vocab to fill in. I'm actually going to jump around. These are kind of out of order. So we are going to start with what a quadratic function is. So a quadratic function is a function that has a degree of 2, so a second degree function. Couple examples of what those are. You guys have seen second degree functions before. So it could be y equals x squared plus 3. The highest exponent is 2, so this is a second degree function. We would call this a quadratic function. Another example may be f of x equals 3x squared plus 2x plus 1. That's another quadratic function. So a function where the degree is 2. Next, we're going to move on to the quadratic parent function. So quadratic parent function, we're just going to throw in what the equation of that is. F of x equals x squared. And then let's just make a note that this is going to be the simplest function in the quadratic function family. And what we mean by the simplest function, there is no translations left or right, up or down. There's no stretches or compressions. There's no reflections. It's just the most simple quadratic function that exists, and we call that the parent function. And for a quadratic function, it has the equation of just an x squared. It could be y equals, f of x equals, g of x equals, but the function itself is just an x squared. All right, so next we're going to move on to parabola. So a parabola is the graph of a quadratic function. So for example, a linear function, the graph looks like a line. A quadratic function, the graph is a parabola. So below your vocab chart, let's actually start drawing, and we'll fill in some more information as we learn the vocab. So here's what a parabola looks like. It's going to go through the origin. It's going to curve up on one side and curve up on the other side. So that shape, that graph right there, that's a parabola. And then this is we'll just draw in our parent function. We won't translate this, stretch, compress, or reflect. It's just your most basic quadratic function. All right. Next, let's move on to vertex. So the vertex is the lowest, or it could be the highest, one or the other, not both, the lowest or highest point on the graph of a quadratic function. So if we look at the graph that we're building down here, the vertex is going to be this point right here. If your parabola opens up, it will have a lowest point. That is our vertex. And for the parent function, the vertex is at the origin every time. It's at 0, 0, because we have not translated this left or right or up or down. And then our last vocab is the axis of symmetry. All right, so our axis of symmetry is going to be a vertical line. It's the vertical line that intersects the vertex, and it also divides the parabola in half. So if we go back down to our parent function we're drawing in, the axis of symmetry, I'll draw it in green because I think that might stand out more, is going to intersect the vertex. That means it's going to be a vertical line going through the vertex just like that. So it actually is kind of hard to see, but right here is where I drew that vertical line. That's your axis of symmetry. And then because it's an equation of a vertical line, it's always going to have the form x equals, and then in this case, our parent function has an axis of symmetry of x equals 0. It crosses the x-axis at 0. So that is a symmetry line. I didn't draw this perfectly symmetrical, but your parabolas, when they're cut in half, the left side will mirror the right side. So if you have a point over here on your parabola on the left, it has a point that mirrors it on the right side, the same distance away from the axis of symmetry. So just keep in mind that if you know a point on one side of the parabola, we can easily get the point on the other side as well.